Let's do a quick review of a few concepts that we already know. And the reason why we're going to do this is that they're going to be very highly used in the next topic that we're talking about, which is called subprograms. So the first review item is something called scope. And we first discussed this and first saw this when we started talking about variables and where we can and cannot define them. We talked about the difference between a local variable and a global variable. Well, what I mean by the term scope is basically where is that variable accessible and how long is it in memory. Those are the two main components. So how long is it in memory, and part of the Java dictionary, of course, and where in the program the variable is usable. Now we mentioned, as I said a few seconds ago, that you can create a variable either globally or locally. Well, what's the difference between the two? Whereas there's the obvious difference in terms of where you actually define it. So global variables are defined outside of the main, but inside of the class. We typically define them just below the class line here, as you can see here. So static int user age 7. This is outside of the main, so it's above the main, but it's below the class line. Now remember that when we do this, we have to define it as static because we want to later use it inside of the main, which is also static. So that's a global variable. Now, how long is a global variable in memory? It's in memory for the entire life of the program. It never leaves. When the program ends, that's when it's finally deleted. Great. In terms of how long is it or where is it usable? Literally everywhere in the program. The easiest way to know where a variable is accessible from is the opening and closing squiggly brackets that it's defined in. So this global variable is defined in the largest set of braces, squiggly brackets, in the entire program. It surrounds the entire program. So that means that that variable is accessible everywhere within those brackets. That's key to knowing the next part, which is what we talk about when we say local scope. So when a variable is defined inside any code block, it's considered local to that code block alone. So this block could be the main or something that we're going to create later on in the next couple lessons. So looking at the example here, I've created a variable int user age inside of the main. So this variable is local specifically to the main. It's only accessible within the opening and closing curly brackets of the main. It's also only in memory for that amount of time. When the main ends, that's when that user age variable gets deleted. So how long is it in memory? Until the block of code finishes executing. The block of code being that area between the opening and closing squiggly bracket. Where is the variable usable? Only in that block of code. That's it. Only that code block. Nowhere else. So when do you use which? I'm going to give you the TLDR, and the TLDR on this is basically you should always try to have your variables as local. Always. Unless it's otherwise not possible for reasons of efficiency and or practicality. Now there is almost never a reason that you can't have a local variable, with a few exceptions. If you ever have a value that's going to be used everywhere in the program, absolutely everywhere, all over the place, then it should probably be global. In almost every other case, it should be a local variable. So let's break this down. So when do you use which? The benefit of using local variables is that the memory is freed up after the code block is complete, allowing other data to be stored. Now that other data could be data by your program or by another program completely. It doesn't have to be yours. The benefit of using global variables is convenience, is that you can use that variable throughout the whole program, and you can soundly have confidence in the fact that that variable exists and is ready to go. Local variables, not so much. You don't know whether, unless you're keeping track of things, you don't know whether you actually created that variable there, inside of that code block, or somewhere else. So the answer is, it depends. But again, ideally everything is a local variable. There are some things that benefit greatly from being global. So I'll give you an example. If you're playing a game like Super Mario Brothers, the original Super Mario Brothers, old school, you have that score variable, and that score that you maintain is everywhere in that program. And I mean everywhere. Every time you pick up an item, every time you walk into an enemy, every time you finish a level, every time you want to look at the score displayed at the top of the screen. When you finish your game, your score is then compared against the high score. So it decides whether your score should topple the high score and take over. So it's used absolutely everywhere in that program. So that would make sense for it to be a global variable because it's used all over the place. Okay? All right. So that is the idea of scope. Now the second concept we wanted to talk about is something called parameters. Again, this is another concept we've already visited before. We use parameters whenever we call a method that's already been created for us. So things like system.out.println. Well, println is that method call that does what? It displays text on the screen. Well, where does it get that text? It's whatever we put inside the brackets. Well, that stuff that we put inside the brackets is required for that method to do its job. Well, that value that we just put in there, that's the parameter. That's what a parameter is. So we've used a ton of these, we've used a whole bunch of these types of elements. So we've used them in math, in our math library when we use math.pow, math.squirt, all these different math.abs. We use it when we want to round. We use it all over the place. Okay, we also use it during string manipulation and those things as well whenever we needed to specify any specific thing. So for example, for substring, we had to provide a start index and an end index. So it's not the numbers themselves or the values themselves that it's the parameters. It's the variables they're stored in, those temporary variables. So for example, if I'm using math.pow and I give it a 2 and a 3, it's not the 2 and the 3 that are the parameter. Those are the values stored in the parameters. The variables that hold that 2 and 3, the base and the exponent, those are the parameters. So what is a parameter? A parameter is a local temporary variable that stores a copy of the data given to it when the code block is called to be executed. So when I call math.pow and I give it a 2, 3, that 2 is then copied and stored into the base variable. The 3 is then copied and stored into the exponent variable, right? When I call println, the text that I send in there, maybe that is actual quotes that says hello world, or maybe that's a variable that says username. It's not username that's stored in the parameter, it's the value of username. So it's going to go over to the memory, grab the current value stored in username, bring it back, copy it, and then put that copy into the println's parameter variable, whatever that variable is called. We don't know. So we see parameters inside of brackets when we call a code block. So anytime that we have those round brackets at the end of a method call, whatever's inside of there, that's where we're populating our parameter values. So system.out.println, it requires a string. We know this, all right? Println is a code block that requires one parameter, a string of text. This could use a variable or a literal value. Here we see hello world. That's a literal value. It's actual value. But we could have just as easily put in a variable, or we could have created a combination of the two, some text concatenated with a variable. That's up to us. Now here's more examples. Math.pow, we have double base, double exponent. So it requires 2 double values. And yes, order matters. We're going to come back to this in a second. So pow is a code block that requires 2 parameters, a base and an exponent, and both of those are doubles. So what do we mean? Okay. Basically, a parameter is a piece of data required for that code block to do its job. If we don't give it that data, it can't do its job. Think about that for a second. If we call println and we don't give it text, well, what does that mean? That's like me telling you to do your homework, but not telling you what questions to do. You can't do it. So we have to supply it with the information required to do its job, and if we don't, it won't do it. In fact, it'll complain, and the code won't compile, and everything falls apart. Okay, so do all code blocks actually need parameters? Do all methods that we've called, all these methods, all these math things, all these different commands that we've used over the semester, have they all required parameters? No, they haven't. If you recall, something like input.nextLine, it doesn't have anything inside the brackets, so we just close the brackets. When we're talking about string manipulation, the trim operation, the to uppercase, to lowercase, these are all methods that don't require any help to do their job. They know what they're doing. They're just working. So in this case, input.nextLine, it retrieves a value and then gives it back to us. It's then our job to store that value, hopefully, into a variable or use it right there on the spot. So there's a couple what ifs here. What if you call a code block but don't give it the needed data? Well, the obvious is going to happen. It's not going to compile. You're going to get a syntax error saying you didn't satisfy the contract. And the contract is very simple. The contract between a method and the programmer is this. The method says, I promise to do my job if you give me the information in order to do that job. So for example, if I had a method that calculated the area of a rectangle, what are the needed values it requires? Well, it requires a length and a width. It doesn't require the area because it's calculating that inside. So area would not be a parameter. But the length and the width would be because they are required for it to actually do that work. All right, next what if? What if the data is given but in the wrong order? So let's go to that math.pow operation for a second. If I call math.pow 2, 3, that means I have a base of 2 and an exponent of 3. So that's 2 to the third power, which gives me an 8. What if I accidentally mix it up and I wasn't sure which order they go in, and I accidentally put 3, 2? Well, that's a base of 3 and an exponent of 2, so 3 squared. Well, that's a value of 9. 8, 9. Well, those don't match at all. So the program didn't break. In fact, it would work fine. It just wouldn't give us what we expected. It gives us unexpected results. This is called a logic error, which we'll come back to later on in the course. But it's not doing what we expect it to do. So it's our job to make sure that we satisfy that contract, we give it the data it needs, we give it the data it needs, and we give it in the right order. Now this could really cause some problems if you had a method that required, let's say, an integer and a string, and you accidentally put them in the wrong order. So remember what happens when we give a value to a parameter, it copies that value into the parameter. Copies, copy. Biggest important thing here. It's always a copy. But if we give it an int and a string, imagine if we accidentally put that in the wrong order. It would try and take the string and copy it into an integer. Well, that's not going to fit. That's like trying to drive a semi-truck into a garage. It just won't work. It doesn't fit. And we'd also be trying to put an integer into a string. That's not going to work either. So we have to make sure that we always specify things in the right order and of the right type. So, everything I just talked about. Good. Final conclusion here. When a code block requests data for a parameter, it's like a contract, as I said, between the programmer and the code block. We have to satisfy that contract. Okay? Now here's the big thing. Take this away, memorize it, please. The data given to the parameter when the code block is called is a copy of the original data. So if the code block changes the parameter's value, remember the parameter is just a variable, just like any other variable. If the code block changes that parameter's value, the original data remains unchanged. The data outside of the method, outside of the code block, it remains unchanged. It's completely fine. And that's what we want you to remember coming out of this. Okay, so that is our review on scope and parameters. Next, we move on.